Good morning. Good morning to everybody. Thank you to participate to our webinar about Tristar 330 AF, high performance Dune generation of trivalent chromium technology for decorative application. Thank you to be there with us. I'm Sandrine Dalbin from Coventya, Italy. I'm R&D coordinator. Together with me, I have two guys, Brad Durking, our international product manager for our all product range, and Alberto Chiappa for our Italian product manager for decorative application and plating on plastics. For organizational reason, all the microphones are muted. You could find on the right of your screen a box where you can write some questions. So if you have some question during the webinar, do not hesitate to write your questions. And at the end of the webinar, we will try with Alberto and Brad to answer you. So do not hesitate to write your questions. First, before to start, I would like to present you our company, a brief summary of our company. So Coventya was founded in 1927. These headquarters are in France, near Paris, in Villeneuve-la-Garenne. We are the third top global supplier for specialty chemistry for surface finishing. We are present in 60 countries, 5 continents. We have 13 manufacturing sites and 9 R&D centers. We have also quality certifications, the ISO 9001 and EATF 16949, sorry. And we are in progress with the ISO 40001 and 17025. As you could see, this is our product range. We have products for pretreatment, for protection. We can supply you zinc alloys, passivation, decorative application, copper, nickel, trivalent chromiums, obviously, like we will see in this webinar. Functional application with electrous nickel, low, medium, high phosphorus, also trivalent hard chromium. We have also product range for precious metal with gold, palladium, platinum, ruthenium, and also nickel-free alloys for nickel-free finishing. We have a range of products for aluminum with all the treatment of aluminum, preparation and anodizing. And we have also to support our customers in wastewater treatment product range for water care. You could find all the Coventya products in all this industry, various range of industry from aerospace, automotive, fashion and luxury, white goods, energy, data storage, connector, packaging, lighting, sanitary fittings, and so on. So today with me, my colleague, Brad Durking. So Mr. Brad Durking, our Director of International Product Management in Coventya Inc. He's also chairperson at the NAV Surfing Technology Advisory Committee. And Alberto Chiappa, our Italian Product Manager for Decorative and Plating on Plastic Technology. Alberto follows also our most important customer in the decorative market. So I will pass the word to Mr. Brad. Do not hesitate to write your question on the right of your screen on the boxes of questions, and we will answer after that. Brad, I give you the word.
Thank you, Sandrine. Thank you. Good morning and good afternoon to our colleagues out in Asia who are joining this meeting. Happy to be here to talk about our next generation Tristar 330 AF system. It's interesting that when you look historically, the modern period of trivalent chromium plating is really said to have begun with a series of 4 patents in 1927 to 1929. So these were the first systems. The basis of those technologies were crystalline chromic acid, chromic chloride actually, in various salt forms. So, and then they used soluble chromium anodes at the time. And basically the chromic acid was formed at the anodes and was reduced with oxalic acid and hydrochloric acid to make the trivalent chromium. So we've come a long way since then. And some of the first salts that were used ammonium chromium oxalate, which gave a much better solution than any other trivalent salt. So a lot of the systems were based on that. Chemistry evolved from that period up until the mid-1970s. And then there was a company called Albright and Wilson in 1976 that introduced many markets a new Chrome 3 plating process, and it was introduced into North America as well. And that's the basis for a lot of today's platforms and technologies. So from the 1980s to year 2000, trivalent chemistry and trivalent applications continued to evolve to where they are today. And then REACH comes along and changes the entire landscape of what we have to do from a research perspective. Next. With REACH, the regulations since about 2010 have put an environmental target on hexchrome compounds. And so over the course of the evolution of this time period, there was a sunset date set for September of 2017. Of course, a lot of companies were not very successful at implementing replacement technologies. And these are replacements not only for decorative chrome 6 and etching of plastics, but there's a whole range of things under REACH that are using to eliminate that. So the point is, today with our Tristar 330 AF technology, we'll review in this webinar, we're going to talk about that and how it relates to the current status of where we are. Next. As we said, September 2024 is approaching very quickly. And our Tristar meets the requirements for use 3. So to replace Chrome 6, Tristar technology, trivalent plating technology will meet that use. Also POP etching. And with our silicon bond technology that's non-chrome etching, that's not the purpose of today's webinar, but we do have technology both at the front end of the plating line and also at the back end of the plating line with the Tristar 330 series that we're going to talk about today. Next. So we have a family of Chrome 3 technology. Here's just some of the benefits. One of the biggest differences between trivalent technology and hexavalent technology is with hexavalent, you need fluorinated surfactants, PFAS or PFAS types of compounds, carbon fluorine substances that reduce the emissions of Chrome 6. With trivalent, you don't need these compounds. So automatically with today's new regulations and push to remove these compounds from the environment, we don't use them in these technologies. So we're already ahead. These are simple to operate systems compared to Chrome 6 and consistent uniform deposit appearance. I think the application is easier because we don't have problems with chrome burns and other types of defects you would get from Chrome 6 systems, but these have consistent corrosion performance. One of the things that we've done to improve the corrosion performance is introduce post-treatments that Alberto Chiappa will talk about in the next series here. Anyway, we've got basically both types of chemistries. We've got a Tristar 300, which is a chloride-based chemistry, which have a whole different set of attributes. And then today we're going to talk about the Tristar 330 AF, which is sulfate-based chemistry. And again, these meet all the OEM requirements that we need. What we can say in this newest generation of trivalent chrome, sulfate-based, it's ammonium-free too, which is a very important aspect of this new platform. It was developed by Coventya, and we started introducing this in 2017. The process chemistry has different modes of system operation, which is something unique that a lot of sulfate systems do not have. We'll talk more about those unique properties in the course of this webinar. It also, the process offers very, very outstanding performance over present state-of-the-art. So that's why we feel this technology platform is the next generation of what you will see in the market, because it has so many advantages and so much versatility in what it will do. Next. Of course, Chrome 6 is applied over a lot of nickel-plated surfaces to provide decorative appearance, but also some corrosion performance properties as well. In the case of the Tristar 330 AF, though, we've been able to actually adjust the operating mode of the chemistry to focus in on one or two of the important attributes. So if your customer is very focused on color, if they want a visual color that looks like Chrome 6, the blue, the aesthetic color that's similar to hexchrome, we can set the chemistry up to operate that way. And we've done a lot with colorimetry, the CIE, LAB, Alberto will talk about, but we can achieve deposit hue colors obtainable from a -0.5 to a -1.5 in the B value. And Alberto will explain that momentarily. If the customer needs decorative, of course, they're applying it for decorative reasons, but they need more functionality out of the system. What do we mean by functionality? We need to meet the high demands of either a high neutral salt spray requirement or a CAS corrosion resistance. And in that case, we've set the chemistry up a little bit differently, and we'll show you those differences shortly. But in both performance applications, we can even further improve the performance of corrosion using a new post-treatment system called Tristar Shield. It's a Chrome 6 free post-treatment, it's electrolytic, and it does a wonderful thing to the deposits here to improve their overall performance. So we've really been able to, with the R&D group, develop a system that is very sustainable today, but also into the future. And that's what we see. So Tristar 330AF, Tristar Shield, our Chrome 6 free post-treatment, and we have also for furniture goods and tubular goods where you have the ID surfaces that require some protection because plating doesn't go there, of course. We have our Tristar Post Dip HM, which Alberto will speak about also. From the research that our company's been doing for 15 years plus in the development of these technologies, we've always maintained that, of course, we need them to be Chrome 6 free, but we want them to be ammonium free, cobalt free, and of course now PFOS, PFAS, PFOA free in the system. So that these are important characteristics that we've had in mind with the whole development of the whole platform. So some of the main features here again, let's focus on the two different modes of operating. Why would you need that? Again, if we're going to focus on the functionality of decorative applications, again, where you need high corrosion performance, or you need some type of higher level than just color performance, and we use these on interior and exterior automotive vehicle components. In the plumbing, sanitary fittings area, there's a lot of need for those high corrosion performance applications. But also on the same spectrum, people like the color. And that's always been one of the downfalls of the trivalent technologies until now, is being able to achieve a color that looks like Chrome 6 deposits. And again, people want that look without the appearance. And there's differences why we've struggled to meet this as an industry. But today, the struggles are no longer important because we can meet those LAB requirements for the blue color. Some of the features and benefits, again, there's a lot that can't be covered in this type of a webinar, but to just give you an overview, it is a production proven process. Alberto and his team, they're hands-on, they've done a lot with this technology in Italy and other parts of the world. So we've got a lot of experience since 2014. We can meet both the functionality, performance requirements and applications. Corrosion resistance is good. We can get the decorative performance applications, the color that people want, and we can balance the system to do a little bit of both. And that's important. We have high throughput, high deposition rates. You'll see again a difference in what we target for functional application versus decorative. We can achieve very high neutral salt spray resistance today and good CAS resistance when we incorporate the use of the Tristar Shield electrolytic post-treatment system. And so one of the other elements that are important today is people are looking at nickel leaching or the leaching of nickel layers in a lot of different applications. And with Tristar 330AF and the Tristar Shield, we can show, and we've demonstrated that we equal Chrome 6 from the standpoint of the reduction of leaching of nickel from these coatings. Of course, we've always had in mind the design of ammonium-free types of technologies. Also, with trivalent chrome systems, they need to be purified a little bit differently than chrome 6. With chrome 6, we worried about just a porous pot to keep trivalent chemistry reoxidated to hexavalent chemistry. But here with trivalent, the electrolyte is purified with a resin system, and we can dummy plate if we have to. So we can do all the same things with trivalent technology that we've been successful with over decades with chrome 6, just avoiding the chrome 6 altogether. We can plate over a very wide range of current density, excellent throwing power, and one of the real big differences between trivalent technologies to chrome 6 is the fact that you can overcome weaknesses with when you have problems with rack tip connections on parts. Nickel passivity is stopped. You can do current interruption in some applications, and you don't see a negative effect on the deposit like you would with a chrome 6 system. So a lot of advantages of chrome 3, and that's why it's really important to try to adapt these technologies to replace chrome 6 wherever you can. The process sequence is very similar. Once you get to the nickel, active nickel surface, we have some rinsing, and then we apply the Tristar 330 AF technology. And we've got rinsing, and then if you need the additional corrosion performance protection, we have the Tristar Shield and the post-dip. Again, Alberto will talk quite a bit about these technologies and some of the advantages that we've seen with them. One thing that people see a difference in from chrome 6 is the number of additives with trivalent technology. This is not really a disadvantage. It looks overwhelming when you see the number of additives, but we've been able to separate them so that it gives us more flexibility in meeting some of the requirements of the application. So we have different additives. Their use and the concentration ranges will vary depending on which application we want. So don't be too overwhelmed by this. We've made it actually with more flexibility by having more additives versus a chrome 6 technology. But these are the way all trivalent technology platforms are situated from their chemistries. If we look at decorative performance versus decorative functionality performance, and again, I know the words are a little strange, but we're talking about more functional application need for the deposit versus a more decorative. Some applications just want it to look very nice. They don't have all the corrosion performance requirements. So we set the system up here, as you can see on the left. If we want to maximize color, the blue color, for instance, we set up the decorative performance parameters, and we can achieve the blue color hue, LAB value, the B value of -0.5 to 1.5. And these are the properties. We're basically operating at lower chromium metal, and we adjust the complex and one of the other additives. We also, for the functionality applications, we want faster deposition rates. We want to build a higher thickness and a quicker rate. So that affects color, having the higher thickness. It's less blue, but of course you get the higher corrosion performance. So we've balanced the system to be able to meet both. Next. If we look at some of the details of the working parameters, again, one of the differences, operating temperature between the decorative performance, the pH of these systems. One of the biggest advantages of trivalent technology is a much higher pH than chrome 6, which is -1, very acidic. These are less acidic than those. But again, we operate at different current densities. We use titanium anodes with the mixed metal oxide coatings on them for this technology, and it operates very successfully under those guidelines. So in a quick summary of where we are, we've got 4+ years of production experience. And again, Alberto Chiappa will talk about that in our replacement of chrome 6. It's got a very uniform aspect, wide range of current densities, which is very beneficial for a lot of complex parts. It has excellent throwing power. The distribution is very good over current densities. We have limited defects, by current interruptions or other types of racking issues. We can control the contamination through a resin system, purification system. And it is a patent pending technology, which again, it's a much different platform of sulfate chemistry than is out in the marketplace today. And that's why it's very unique. It's very important because of that fact. And it will be the next generation of what we see in the replacement of Chrome 6 technology. So with that, Alberto Chiappa will talk about the process and deposit performance characteristics. And then afterwards, we'll do a quick summary and then we'll be ready to answer all of your questions. So thank you. And Alberto, I turn it over to you.
Okay. Good morning, good afternoon, everyone. Thank you, Brad, for your presentation. I am Alberto Chiappa, the Italian product manager for Deco and POP processes. In the next slide, we will analyze Tristar 330AF process and deposit performance in terms of CA Hill Lab color, efficiency, very good resistance to cleaner dedicated to sanitary fittings, corrosion test, soot spray test. CA Lab gives the opportunity to understand the color fixture of the chromium layer. You have 3 color coordinates indicating different color shades. The L coordinate has a range between 0 and 100. It is the maximum value representing the white color of the maximum reflection. 0 is the maximum absorption, that means black color. The coordinates A and B, on the other hand, have no limit but positive or negative value. The negative A coordinate control green color, while the positive one control the red color. The positive B coordinate control yellow color, while the negative one control the blue color. Well, this table compare hexavalent and trivalent coordinates. As you can see, the value of L and the value of A are very similar. Regarding the B value, we notice that the decorative version is very similar to the hexavalent coordinate, with a very negative B value of minus 1.5. Even the functional version have a B value tending to the negative. In summary, both versions, but mostly the decorative one, can be mounted with hexavalent chromium items without noticing the difference. We compare now the deposition efficiency of hexavalent chromium plating and Tristar 330AF. As you can see, with the both version, but mostly the functional one, the Tristar 330AF has higher plating rate. This allows the process to be installed without changing position of the chromium plating tanks and the system cycle. In addition to that, the processes does not lose in terms of performance. Okay. Most important cleaners used in the sanitary fields have been testing according to the sanitary specification. The following have been testing: Mastorlindo, Vinegar, Napisan, Sidol, Bref, Viacal, and Tristar 330AF does not discolor or degrade when exposed to these cleaners. Well, next topic is corrosion resistance. To pass the test in the production cycle, you need to hit a new post-treatment step called Tristar Shield. Tristar Shield passivation, it is a process that is free from Chrome 6. It is a single step. All additives are analyzable. It is easy to be installed, and its use does not change the deposit aspect. Finally, please remind that this process is patent pending. Well, trivalent chromium plating cannot create a protective oxide film like hexavalent chromium. In fact, the layer of the deposit with no post-treatment allows low nickel corrosion with the formation of oxide on the top of the surface. Only the combination between Tristar 330AF and Tristar Shield create an oxide film formation, sealing the micropores and retarding the nickel corrosion. These are the tests passed thanks to the combination of Tristar 330AF and Tristar Shield. Neutral salt spray test, the natural exposure and storage, and the last nickel release. The table recaps the working parameter of Tristar Shield. It works at 28 degrees, 9.5 pH unit. It has a density of 1.5 mm, and the anodes to be used are in stainless steel 310, 316. We also recommended a solution filtration. The passivation is electrolytic. In this case, Coventia supplies the rectifier to ensure process performance. Okay, now you can see how the Tristar Shield on brass or zinc die cast base material help passing the 480 hour of salt spray with no appearance of stain, holes, or other change due to corrosion. On an iron base, Tristar Shield help passing the 24 hours salt spray test. This result is comparable to hexavalent chromium plating. As you can see from the picture, Tristar Shield managed to protect the less covered and more porous area that are easier to be exposed to rust occurrence. As shown in this photo, all trivalent chromium plating shows some salification or corrosion beginning. It happens because the surface layer has not been treated with a protective post-treatment. After Tristar 330AF, using Tristar Shield allowed to solve both natural exposure and storage issues, fully preventing surface corrosion to start. Well, as you can see from this table related to nickel release test, the results of Chrome6 is comparable to the combination of Tristar 330F and Tristar Shield, which passed the test in excellent way. Even Tristar 330F passes the test. So let's recap a little bit about Tristar Shield. It is a rich compliant, industrialized by several customers. It meets the requirements related to salt spray test, such as 1,000 hours for a POP application dedicated to automotive, 408 hours for items made of brass or zinc die cast, and 24 hours for steel. It enables meeting nickel release requirements. It's very easy to install and use. It needs just a single step. It is good for all Tristar deposits. The light ones are Tristar 300 and Tristar 330AF, and the dark ones are 725, 750, 760, and 765 processes. Well, Another problem is linked to the formation of rust inside the iron tube. It is caused by chrome 6 that doesn't passivate the inner tube. For this reason, we hit another step to ensure protection inside the tube. This step is called Tristar post-dip HM, which is added after the Tristar shield. The Tristar post-dip HM is a chrome 6-free post-dip which increases the resistance to corrosion due to humidity. It decreases the resistance to abrasion. It limits the fingerprint and the deposit doesn't no change in terms of color. It mainly used to protect inner pipe, assuring eye protection and the reduce of rust. Now, this process is used by one of the major furniture manufacturers based in Sweden. Finally, let me show you the application field of Tristar 330 AF. To name a few: automotive, sanitary fitting, lightings, and many more. Thank you for the attention. And now, Brad, please go on with the conclusion. Thank you.
Thank you, Alberto. Conclusions. Where can we conclude? The reality is that we've evolved the technology platform today. We're Tristar 330 AF specifically from our family of Tristar processes. Work over plating on plastics applications. They work on brass and zinc die-cast plating applications and steel applications. So we can fully replace Chrome 6 decorative plating technology with the Tristar in these applications. And we meet or exceed, in some cases, the automotive OEM requirement standards and some of the other more stringent requirements for the sanitary fittings companies, as Alberto demonstrated, performance against a lot of the household cleaners and things that are there. So we have very good corrosion performance from these technologies today. And we have added protection afterwards, either with Tristar Shield or the Tristar Post Dip for tubular type work. Next, if we look at Coventya non-Chrome 6 technology, basically we need, we need the post treatments because, as Alberto said, Chrome 6 is very good at passivating unplated surfaces in the case of steel and things like that. With the trivalent technology, it doesn't do that. So we have to give it a little bit of help and use that. We can use the Tristar Shield and that combinations thereof. We have several customers that are already really in the full Chrome 6 free sequence. So they're going to meet the demands by 2024 September. So the real question is, will you be ready when September of 2024 comes around? And it's not that far off, so you should start looking today to replace Chrome 6. And the Tristar 330 AF is the perfect platform of technology to do that. Next. We're going to continue to see a Chrome 6 free future. Reach isn't going away. There's, regulation, more regulation. We have to chemically look at our technologies. It's one of the reasons why Coventya keeps a fully staffed R&D team, because we're constantly having to reinvent our technologies. And Tristar 330 AF is one of those examples. And again, in addition to reinventing and developing technologies, now with the silicon bond process, that's our plating on plastics metallization process, we can eliminate the use of Chrome 6 etching at the front end of the plating line. And at the back end with the Tristar 330 AF, we get rid of Chrome 6 decorative technology with the trivalent. So we can support the full customer getting out of Chrome 6 today, which is a very important goal for our company, and it's good for the environment and to maintain sustainability as well. Next. If just to summarize again, we have developed the next generation of sulfate chemistry. It's very versatile. We can meet all types of production applications. And again, we've had this in production for 4+ years. This is where Alberto's done a lot of hands-on experience and training some of our other colleagues at Coventya and getting the knowledge out. This has a very, very uniform aspect and color over a very wide range of current densities, has excellent throwing power. And we can control the contamination with the purification resin system. Our Tristar resin system will work. And most importantly, don't forget it's patent pending technology, which means it's different. It's something not like the other technologies out there because we've been able to protect it with patents. So it is a different platform of chemistry and it is the future. So for Coventya, this is our goal. This is very important for us. And that's our tomorrow is today. Next. So I guess we're at the end of the actual formal presentation. We appreciate you taking the time to attend. And I think now, Sandrine, if we're ready, and Alberto, for questions and answers, we'll be happy to entertain those for you.
Yes, thank you, Brad. Thank you, Alberto. Thank you to both guys. The presentation was great. There were many information, many details. Thank you, it was clear and I think easy to understand to our attendees, and many questions arrive about that because many information. So some question, maybe technical question to Alberto first. Some question arrive about the anodes. So you said that the anode should be of titanium mixed metal oxide, right? So does there is some particularity which kind of anodes are necessary for the Tristar 330 AF?
Or Coventya has tested a number of anodes manufacturers, and only some of these it's okay for our process. Nothing. So
okay. Some other question arrived about the pollution and the use of the resin. So yes, so which kind of pollution is damages for the Tristar 330 AF? And so you manage it with the resin, right? Is it the right way to manage pollution?
Yeah. The problem of pollution for the Tristar 330F is copper, zinc, iron, nickel is a metal pollution for the processes, and the iron, the ion to eliminate this pollution inside to the process, and it's possible to make the dummy plating also for eliminate the pollution inside the bath.
Okay. In fact, some other question arrived, yes, if dummy plating is necessary, so we can manage both with resin and dummy plating.
Yes, yes, yes.
Okay. And okay, one other question arrived, it's, does the result you presented after neutral source pretest are also the result with the blue tone color? The result after 480 hours of neutral source pretest were very good. And does it also possible to attain this result with the decorative aspect of the Tristar 330F and with the blue toned color of minus, very negative value of B?
Yeah, the performance remain stable in the time. And for this reason, the aspect after 480 hours to salt spray is a good result because maintain the color and the stable performance of the corrosion.
Okay. Another question arrived. Does carbon filtration is mandatory for Tristar 330 AF?
is not mandatory, but it's possible to make if some organic pollution go inside in the bath, possibly to drag in before the process.
Still about pollution, does Chrome 6 pollution can be a problem for the Tristar 330 AF?
Yes, it's a big problem for the Tristar 330 AF. In fact, when install the Chrome-free process, is important that tank and all the system is completely neutralized to Chrome 6.
Okay. Another question about the Tristar shield. So which kind of anodes are necessary for the Tristar shield?
For Tristar shield, the anodes base material is stainless steel 310, 316.
Okay.
Base anodes.
Okay. Another question was about the Tristar post-dip HM. Does the Tristar post-dip HM has an anti-fingerprint or dewatering effect?
Okay. Tristar post-dip HM limit the fingerprint and create some film on the surface and create this waterproof system.
Dewatering surface.
Dewatering surface, yes.
Okay. Must we use the Tristar post-dip HM for all the applications?
No. The applications for steel is important. It's very important. Sorry, Brad. It's important for the inner tube.
Yeah, I mean, again, Chrome 6 is known to passivate unplated surfaces of steel where you don't get the corrosion. When you switch away from a Chrome 6 to a Chrome 3, there's more tendency for corrosion in unplated areas. So the inside of tubular work and furniture, steel surfaces exposed, you need to add protection. And that's where the post-dip HM comes into use. So yeah, I don't think you'd want to use it unless you've got tubular work. As Alberto, you've said, it's not for every application, but for some.
Yeah.
Okay. Another question arrived, because I have some notes about the question and some other arrived in the meantime. Which kind of, you speak, the Tristar shield is an electrolytic process, right? And we need a specific rectifier.
Yeah.
Okay, so
yeah, it's basically a process. So the R&D work, it's a very specific type of a rectification, and we're creating a very type of an oxidation on the surface, if you will, of the chrome. And so it's important to have the right equipment. And so it's not just any customer, any applicator can just set that up. It's specific to a certain type of detail.
Okay, perfect. Many questions arrived. Another question is, where is currently in use the Tristar 330 AF in this moment? So
you mean applicators? I think, don't we have over 50,000 liters, or I don't remember the total, but we've got a lot of volume of solution at applicators, customers.
Okay, perfect. Many questions arrived. Maybe we cannot answer to all, but in any case, we have the details of all the questions. We will answer to everybody, maybe by email. You will be also maybe contacted by our local team. Do not hesitate to send us other requests if you need about the Tristar shield, or the Tristar post-dip HM, or about other product range. You see on the screen the coordinate of Alberto and Brad, so do not hesitate to contact them. You can have a look also to our website. Coventya is also present on social media. You could find Coventya on Facebook, on Twitter, on LinkedIn, and we update often if we have new webinars on this social media. So stay tuned on this to have information about our development and new products. Even if in this moment, in this particular period, it's a little bit complicated maybe to organize meeting or to encounter customer but in a physical way, but we can anyway organize some meeting or some webinars like that. So do not hesitate to contact us, to contact our local team, and it will be a pleasure for us to discuss with new applicators or already some applicators that we supply. So thank you to have participated to this webinar. I hope it has been interesting for all of you. Take care, stay healthy, and thank you again to have participated. Thank you, guys.
Thank you.
Thank you.
Have a good evening, good day.
Have a nice day. Thank you.
Thank you.
Bye. Bye-bye.
Bye.
Bye.